Hello, everyone. I'm Jeff Gunderson. Welcome to the Delta Analytics Data for Good presentation series. So today we're going to be reviewing the project with Give Us the Floor to develop classification models and analytics to gain insights into the well-being of youth. So for the agenda today, we're going to be going through introductions to Delta Analytics and Give Us the Floor. We'll be talking about the scope of work of the project, how the solutions were developed. We'll give you a demonstration of the solution, talk about the impact of the solution, and at the end we'll have some time for questions. But if you have questions, just put them in the chat. We'll try to handle them as we go along in the presentation. That works out better sometimes. So first, let me give you a little bit of background on Delta Analytics. So Delta Analytics was started about 13 years ago by a group of data scientists who wanted to leverage data for good. Delta's mission is to help nonprofits with the skill gaps that many face and leverage their data for good. Since 2013, we have completed about 80 projects with about 28,000 hours of time. And in that process, we recruited over 300 volunteers. And we did all of that without charge. So for the project we're talking about today with Give Us the Floor, we're very happy to have helped them this year with their mission. The project that we're going to be talking about is actually the third project. So the first project, we developed models to classify the well-being sentiment of youth. And in the second project, we developed an initial dashboard to show the analytics for the well-being metrics. And in this project, we operationalized the solution and refined the dashboard. So I think we've had a good series of projects where we're building a solution that provides impact for the mission of Give Us the Floor. So I'd like to turn this over to Valerie Grisson-Alsop. Valerie is the founder and director of Give Us the Floor.
Hi, my name is Valerie, and I'm the founder and executive director of Give Us the Floor. What we do is that we help LGBTQ youth, 13 to 24, in distress via an online program, peer support online program, where they help each other. We train young facilitator to help their peers, and it's really youth-led, community-led, and we have self-reported very, very good impact, because after only 1 month in the program, 83% of them said that they've been helped with their struggle, and 70% of them said that they improve their mental health. But all that is self-reported. So one of the reasons we collaborated with Delta and was so happy and thankful to have their help is to be able to have other proof that just the self-reported, to be able to go in the conversation, in the data, and see that indeed we could see an improvement in the well-being of young people.
Very good. Thank you, Valerie.
You're very welcome.
So next, I'd like to turn this over to Akshata Kini. Akshata is a fellow with Delta, and she was the team lead for the project.
Thank you, Jeff. Starting off with introducing the team, we are a team of 6 data science fellows who brought and of course Jeff, Sean, and Jay for their guidance throughout the project. Let's move on to the next slide. And to start off with what we built for Give Us the Floor, like Jeff mentioned, we had 2 main work streams. The first one was productionizing the sentiment analysis pipeline we fine-tune the 5-4 mini model to score each user message within the platform on a scale of 1 to 5, 1 being very negative, 5 being very positive. We fully deployed a fully automated pipeline on Google Cloud Platform itself that handles data ingestion, sentiment scoring, and storage. The second work stream focused on using those results to kind of build an interactive dashboard. We use the net sentiment score to better capture overall sentiment. We created cohort analysis to track how user sentiment and retention change over time. And then we also built a state level heat map to identify sentiment trends. Now we'll get into the technical details of the model itself. And to start that off, I'll be passing it on to Shobana.
Thanks, Akshita. Next slide, please, Jeff. Okay, as Jeff mentioned, this is a 3 years kind of a meta architecture. Is a first code that's coming and sitting in the BigQuery. We consume that, we cleanse it through our data processing notebook, and we let the LLM, which is nothing but the Pi model, that run on the cleansed data to produce the sentiment score. And once that kind of a goal layer is reached, we then evaluate the metrics that is used by our dashboards. So everything is being automated from the raw layer to the business layer that we call it. So through Vertex AI pipeline. So I would like to show it in my screen, like how the pipeline has been set up and everything real quick. But before then, this architecture has been broken down into 2 pieces. One is for the development aspect of it. If we are in future changing anything in the model, or I need to see how my model is performing over time, everything is being done through the can be done through the development pipeline. Those are separate notebooks that's been separated from what's been running in the production. So today we are following the champion challenger model version of finding what model to use through our prompt registry, which is nothing but a set of JSON files that we are maintaining within our repository. So if you want to change any of your model or the prompt that is being used in the production, you don't have to touch any of the pipeline code. Rather, you go and change it in the JSON files that's been maintained. So for any CI/CD process, like if you are doing continuous development, which you need to integrate into a pipeline, everything has to go through a JSON rather than going and editing the notebooks. So that way, that made it simpler on the high level for the developer rather than going and touching the pipeline underneath. And once this pipeline is scheduled to run bi-weekly. So it consumes the data from 1st to 15th and completes the one production run, and from 16th to end of that month, and those is being appended to the tables that have been created. So Jeff, if that's okay, can I share my screen real quick? I hope my screen is visible.
Yes.
Okay, so if we go to agent platform, which has been renamed from Vertex AI. So under models pipeline, we can see our scheduled pipeline, which is scheduled to run bi-weekly. So if you go here and see, you can see what are the upcoming runs that's been scheduled. And from the runs perspective, these are the run which has been running from June 15th is what we started this. So you can see we have almost 4 runs now. So if you go inside the run, you can see the DAG of what it is running. And first is the data processing, as I showed in the architecture, and the sentiment analysis has been broken down into 2, one for channel and one for group, just to just sure we make sure they both run in parallel, since they don't have dependency and we have less runtime. So we made it as in parallel. And then next goes the data post-processing, which is nothing but the business layer metrics that we've been creating for the dashboard. And next is the evaluation, basically being taking the statistics of the data, which I would show in short. So again, this pipeline is designed in a way that it's been completely parameterized, so you don't have to go and change anything. If you want to change the table, or you don't have to reinvent the wheel. All you have to do is point it out to the correct parameters in the table, so the pipeline picks it up from the code. So as a real quick, I would like to show the big table, just the evaluation. Okay, and the other thing, this pipeline is completely monitored. So we do created a process log. So any failure, you don't have to go and debug it yourself. So you can check it out from the process log table. So it's going to record you what went wrong. And every table that this pipeline is emitting has an audit column, which is nothing but the pipeline job run ID and the run ID that lets you figure out what went wrong and where. And you can find the error if there are any errors, and all and each and every record of what is happening inside the pipeline has been tracked here. And the second thing is the, one second, let me get the, I forgot the table name. Let me get the table name. Okay, inference monitor. Okay, as I was mentioning, yeah, okay, I couldn't find it, never mind. But what I was trying to say is all the evaluation that we are doing, like how many messages are score 1, score 2, score 3, everything has been captured for this, just to figure out are there any drift in the data, all those good stuff. So all those tables are present. We do have the run book, which tells you exactly what tables are they and how you have to run this pipeline, how you have to debug, and everything is present in the README and the runbook files, which you have access to. And second thing, as I was mentioning, the prompts and the models are always sitting in the config as a JSON format. So if you have to change anything, you can change it here, so the notebooks gets it picked. Coming back to the architecture, I'll stop sharing. Over to you, Jeff.
Okay, thank you. And that was very good. So I'll bring back the presentation.
Yeah. So everything has been audited and governed through a service principal, which we worked on. I think you remember. So the pipeline is running through the service principal, and it's been audited by the audit columns in each table. So it's easy to track and debug if anything goes wrong. And all the source code is sitting in the bucket, Google Storage bucket. So we have all where the location, everything is present in the README file, so which is easy for you to go and get it. And all the notebooks are self-explanatory. So if you need to understand anything inside, so each column represents what they are doing in the notebook cell. Okay, moving on to the cost metrics of it. Over next slide. Okay, to run this pipeline, how much does it cost? So for the LLM inferencing, we are using the GPU T4 GPU NVIDIA cluster and the VM of N1 high memory 8 virtual memory. So that's cost around 90 cents per hour. So if you go to the Google pricing calculator, that would give you around $600 for running the virtual machine 24/7 for a month. So, but ours is on demand. It only picks it up when it's needed, when the pipeline is scheduled. So it's gonna run for an average of 30 minutes each. So there are 2 GPU clusters, which is for 1 hour. If 600 divided by 730, that's what bring us to 90 cents per hour. So that should be the cost for running this LLM inferencing. And the other, the post-processing, pre-processing, all those run for 5 minutes each. So that would roughly cost us, 3 cents. So on an average, it comes down to $1. That's what we are expecting per run, and a monthly average of for 2 runs, it's going to be $2. For annual, it's expected around $25. So if you see any discrepancies in your billing for this pipeline run, do let us know so that we can debug it real quick before we close the fellowship. And yeah, next slide, please. Over to you, Jason.
Hey, y'all. I'm Jason. I wanted to talk through a bit about our model and prompt selection real quick. So yeah, as Shobana mentioned, we ran this kind of champion challenger construct. So we tried the kind of initial prompt and then kind of challenged the V1 prompt against it. For our model selection, we were aimed at smaller models. Obviously, we want to run those pretty cheaply. And as Shobana mentioned, we're running it on T4, which is one of, I think, if not the cheapest GPU we can get in GCP. So picked PHI, Qwen, and Mistral, smaller models to compare here, fine-tune those. And then interestingly enough, I think the biggest gains that we saw were from the prompt optimization. So you can see we almost doubled performance on a few of these models, going from V0 prompt to V1. And interestingly enough, the V1 prompt was actually the highest performing, just from asking Gemini basically, hey, here's our target model, here's kind of our use case, can you optimize this prompt? And anything further than that, kind of targeted additions aimed at different failures in the data set or anything similar, ended up either causing regressions or an increase in errors. So yeah, ended up going with that V1 kind of champion prompt with Gemini optimization. Another issue that we were solving for here was model errors. Since these are really small models and we did some fine tuning, any kind of prompt tweaks or actually a lot of results from the V0 kind of just handwritten prompt resulted in error outputs from the models. Yeah, so helping with having the Gemini prompt helped with the errored outputs as well. Yeah. And we can go to the next slide. I'll pass it over to Shonak, or isn't here?
Yeah, I can start with data pre-processing. So just to give a brief about what we did with the data, we ensured that the data that we're using for the model is the most optimized version. So we used 2 different tables for this, the channels data and group data. We made sure that we are only using the user messages and separating that out from any facilitator message. So we did that in the pre-processing stage. We joined the channel and group tables together. And as a finalized version to feed into the LLM, then we also used that data to score it from 1 to 5, as I mentioned earlier. And then we added a semantic layer above that. So we also did the post-processing within Google Cloud Platform. and use that data to then feed our dashboard that we built in the Looker Studio. And we move on to the next slide. To start off with, the metric that we used, the main metric that we used within the dashboard is that we moved away from the average sentiment score that we were using earlier. Because one challenge we were facing with using average sentiment score was most of the user messages were neutral. And as a result, the average tended to stay close to 3. And it was making it difficult to detect, all of the subtle changes within the overall user sentiment. And to address this, we decided to use net sentiment score instead, which calculates the percent of positive messages minus the percent of negative messages. It kind of excludes neutral messages. This gives a much clearer picture of the overall sentiment to show whether a sentiment is trending positively or negatively rather than just like a focused view of the average score. So that was our star metric that we used for all of the reports that we built. And now that we've discussed how we measured the sentiment using net sentiment score, I'd like to show how we use the scores to build out the dashboard. We'll go to the next slide for that. So in this slide, I'll highlight 2 key components of the Looker Studio dashboard that we built. The first one is, Jeff, can we go back to the previous slide?
Oh, sorry.
The first is the cohort and retention sentiment analysis, where we group the user by their joining month and then track how the sentiment and retention evolve over their first 12 months. This helps us understand whether user experience is changing over their life cycle, that is the first 12 months after they join Give Us the Floor app. And the second report that we built is a state level heat map, which shows the geographic distribution of net sentiment score across the US, allows us to quickly identify any regions with stronger sentiment, as well as any areas where there may be any opportunity for further analysis if it's like trending way negative in that state. And I'll pass it on to Shri to give us a quick demo and share a couple of sample insights out of the dashboard.
Hi, everyone. Good morning. I'm just going to quickly share my screen to have the demo. So as Akshata did mention, we used 2 different ways of visualizing the data. We built a Looker Studio dashboard with 2 main views. Each answers a different business question that we thought about. One focuses on the user sentiment score over time through these cohorts, and the other one looks at sentiment geographically across the US. Just to give a quick demo, with the cohort dashboard, this is where you can understand the user life cycle across the app. Each row represents users who joined in that month, and each column represents another month in their journey. So instead of comparing calendar months, we're comparing users at the same stage of their experience. These colors represent the net sentiment score, while the retention values let us see how many users are still active at that point. For example, you can follow a single cohort through their later months and see whether sentiment improves, declines, or stays relatively stable. This will help answer questions like, are newer users having worse onboarding experience, or do users get happier as they continue using the platform? Since this is built in Looker Studio, we do have the option of adding multiple filters on it. That way it's a little bit more interactive without needing the SQL or Python query. It's easier for non-technicals to explore the data. Just transitioning to insights for this specific visual, you can see that the clearest finding is that the early engagement does weaken over time. When we looked at the first month activity, users who joined around the October 2025 averaged roughly 28 messages each, while newer cohorts from January or February of 2026 averaged closer to 9 or 10. This drop happens before we even see changes in sentiment or retention, which could suggest that there are areas of onboarding or early engagement that could be worth investigating. The other insight is that there is a little bit of sentiment drift that is, we can see. It looks like the sentiment does improve as the cohorts age. However, when you look more closely, we could see that this could also be due to the shrinking sample size. Later months often contain only 1 or 2 users, so those scores could become much more volatile. The second visual that we worked on was a visual for the geographical kind of heat map. You can see how the sentiment scores change across the different states. From this, one of the insight is that some states may appear very negative. For example, you can see like Wyoming, some of these lighter colored are showing a little bit more negative sentiment, whereas the darker colored shows the more positive sentiment. And the circles in gray, they show the number of messages that's available from these states. But again, when you check the underlying data, many of these states only have a handful of messages. So, we cannot conclude that these regions are unhappy, but that this is a small sample to consider. From a product perspective, this dashboard does offer, support in investigation rather than simply reporting these numbers. You could identify a cohort with a declining sentiment or retention and look at what's going on there. And the geographical view does offer a little bit more insight onto where are we having higher message volume, and is that how does the sentiment score show from that certain populations. Overall, these dashboards, they are scoring thousands of individual user messages into something that is easy to monitor across time as the first visual and across state. Instead of manually reviewing these conversations, this is an easy way to quickly identify where the attention is needed and to prioritize any follow-up. But that is our visual. And I will...
May I add something? And so you caught something. We had actually some technical issue where some user couldn't post some messages, and it took us like over 2 months to figure out, because it was not happening to everybody. That's this kind of bug though. So that clearly showed in the decline of the engagement, which great.
Yeah. It's an easy way to see what's going on a big picture kind of snapshot.
Yeah, absolutely.
And I think I'll stop sharing my screen. Thank you.
Yeah, thank you, Shri. That was good.
So I think I just ran through the next couple slides with the demo, so we can just go to the next slide. So these are the insights that I just shared with the visual, the demo. Reading a dashboard is pretty, simple. You can start with the cohort analysis, as I said. This gives a little bit more insight into how the cohort is doing across their journey while using the app. And then, as a life cycle, you get an understanding of the retention rate and the engagement rate. And then moving into the geographical visual, you do get the, whether a particular region is contributing to that trend. This gives a little bit more insight into social elements to the engagement as well. And if both views does point to the same issue, for example, newer users in a specific region are consistently showing lower sentiment, it becomes a strong signal to maybe focus attention on investigating what's going on, if it's the onboarding, the content, or is it the product experience that's, adding to that that issue. Next slide. Like I said, this pipeline is active. Shobana and Shaunak and Akshata and Jason, we've done our hardest and our best that we could to keep this a live dashboard. And I think there's a lot of value even in the dashboard and also the way the work is done with the data. But if you have any questions, please do reach out to any of us on the team, and we would love to maybe give a one-on-one on how to work the dashboard. Thank you.
Thank you, Shri. And before we wrap it up, I just want to take a moment to give us the floor for being such an incredible partner throughout the project. Ireri, for your support, collaboration, and willingness to share your insights helped us make this project a smooth experience. And we appreciated the opportunity to work with the team that is so dedicated to creating a meaningful impact, and which really makes this project especially rewarding for us. And thank you again for giving us the opportunity to be a part of this work. We are excited to see how these insights continue to support your mission, moving forward. And of course, to reiterate what she said, thank you to the team for your contribution and your hard work throughout.
Yeah, can I say thank you too? I want to say I'm so happy and excited to see this dashboard, and thank you so much to all of you for sticking with us for 3 years and developing that project, because I think it really led to something that is going to be so useful for us and for the participants that we're helping. So we're extremely grateful and thankful to have you standing with us. Thank you so much.
Yeah, thank you, Valerie. But as Akshata said, let us know moving forward, how we can help you, or if you're getting insights into your youth that you're helping, let us know. And we may be able to help you, ongoing if you have questions. So
okay, we'll certainly do.
Okay. Yeah, I'm not seeing any questions in the chat. So does anyone have any questions they want to bring up now?
I don't have any questions, but I will take this time to thank the team. It's the first time that I see all the technical parts that you did, and it made my heart really happy to see that everything is documented and really easy to modify. So yeah, thank you so much for all your work, and it shows up, you're great at it. Thank you so much.
Thanks, Ayuri. Okay, well, thank you, everyone. I appreciate your attendance today. It was a good presentation, I thought. Thank you.
Thank you, everyone. Bye-bye.
Okay, bye-bye.
Thanks,
Thank you.
everyone.
Thank you.